starting inside a delayed export approval process rather than a geopolitical announcement, building a cause and effect chain from administrative friction to industrial dependency. Tungsten power is not in extraction, but in who controls the conversion and timing of refined supply. Mood applied, cold and analytical, almost clinical in how the system is described. A shipment doesn't always stop with a headline. Sometimes it stops with paperwork that never clears. In the export corridors tied to China's tungsten industry, the more important decisions rarely look like decisions at all. They look like delays, missing signatures, or a licensing review that quietly stretches from days into weeks without explanation. Outside observers tend to compress that into a single narrative. China is blocking tungsten exports, but that framing misses how the system actually operates. And tungsten isn't behaving like a normal commodity in the first place. It moves through global industry less like a traded mineral and more like a controlled industrial input embedded in policy architecture. The metal itself is visually unremarkable, but its function is structurally sensitive. It sits inside cutting tools, high-temperature alloys, and dense kinetic components used in defense manufacturing. So when governments talk about tungsten exports, they are not really talking about rocks leaving a port. They are talking about what those rocks become after multiple refining stages that only a limited number of industrial systems can consistently perform. This is where most analysis slips. It starts at the mine. Global tungsten reserves are often discussed as if extraction equals control, as if whoever digs the most automatically dictates supply conditions. But tungsten is one of those materials where extraction is almost the least valuable stage. The real bottleneck sits in processing, specifically turning ore into ammonium paratungstate, then tungsten oxide, and finally high-purity powder suitable for industrial sintering. Each transformation removes impurities, but it also concentrates capability into fewer industrial zones, and those zones are not evenly distributed globally. This is where China's leverage becomes visible in a way that mining statistics alone never capture. Over the past 2 decades, China has not only expanded tungsten extraction, it has built vertically integrated refining systems that connect ore directly to finished powder at industrial scale. That integration matters more than raw reserves because it reduces dependency on external processors and increases control over what actually leaves the country in usable form. But control in this system does not usually appear as outright prohibition. More often, it appears as administrative structure. Licensing requirements, quota adjustments, and periodic tightening of approvals for refined tungsten products. And those adjustments do not need to be permanent to be effective. A short delay in export clearance can ripple through manufacturing schedules in ways that barely register in trade data, but show up clearly on production timelines. Defense contractors notice it first because their supply chains have the least flexibility. Industrial buyers follow, especially those dependent on consistent tungsten carbide supply for machining and wear-resistant tooling. At this point, something important becomes clear. No formal ban is required for pressure to exist. It only requires friction placed at the correct point in the chain. But there is a second layer underneath this that rarely gets discussed in commodity conversations. It is not just about control of supply. It is about control of conversion capacity under stress conditions. When global demand spikes, especially during defense procurement cycles, countries that control refining can effectively determine who experiences delay and who does not. This is not always a deliberate geopolitical action. Sometimes it is simply the outcome of constrained industrial throughput meeting sudden surges in orders. But outcomes matter more than intent when supply chains are already tight. There is also a historical layer that tends to get skipped. In the early 2000s, tungsten processing capacity outside China gradually lost competitiveness due to cost structures and environmental regulations in Western jurisdictions. Facilities closed or relocated, and the remaining capacity became more specialized, less scalable. By the time demand for advanced carbide materials surged again, rebuilding that infrastructure was no longer a quick industrial adjustment. So when export licensing tightens even slightly today, it interacts with a global system that has already been thinned out over time. And that thinning is what turns minor policy changes into noticeable industrial signals. We are not looking at a binary world of open versus closed trade. We are looking at controlled permeability, where access depends on form, timing, and administrative sequencing. And that distinction is what most headlines compress into a single misleading sentence. There's a second layer to this story that only shows itself when you stop looking at tungsten as a resource and start treating it like a timing problem. Because in global industry, timing is often more valuable than quantity. You can have tungsten sitting in warehouses in Germany, in the United States, in Japan, but if the wrong grade arrives late or arrives in the wrong processed form, entire production lines slow down anyway. That is the part most commodity discussions miss. They assume availability is binary. It isn't. It's conditional. The real pressure point is tungsten carbide, not raw ore, not even refined oxide. Carbide is where tungsten becomes structurally useful at industrial scale. You take tungsten powder, combine it with carbon under high temperature and pressure, and you get a material that can cut through hardened steel, survive extreme friction, and hold shape under conditions where most metals deform. This is why it sits inside drill bits used in oil extraction, machining tools for aerospace components, and certain categories of penetrators in defense systems. It is not decorative. It is functional under stress. And the catch is this: carbide production depends on consistency, not just supply. A small variation in particle size distribution can change performance. Impurities that would be irrelevant in bulk metal become critical in sintering. So buyers don't just want tungsten. They want tungsten that behaves exactly the same way every batch, every shipment. That level of consistency is not evenly available globally. In practice, a large share of that consistency still traces back to processing ecosystems inside China, where vertically integrated facilities can move from refining to powder standardization without breaking the chain. Now here's where the export control conversation becomes more technically interesting. When people say export restrictions, they imagine borders closing. But in tungsten, the more relevant mechanism is specification filtering. Different grades of tungsten products can move through different approval channels, and those channels don't behave the same way under policy tightening. So instead of a simple stop, what you get is segmentation. High purity powders, especially those used in defense grade or aerospace applications, face tighter scrutiny. Lower grade industrial materials may still flow, but they are not interchangeable in high performance manufacturing. That difference creates an uneven shock through global supply chains. A machining company in Europe might still be able to buy tungsten carbide tools, but a defense subcontractor working on high tolerance components may suddenly find lead times stretching without any formal disruption announcement. And because procurement systems are layered, that delay cascades upward. Tier 2 suppliers adjust orders. Tier 1 manufacturers resequence production. Inventory buffers get consumed faster than they are replenished. No single point looks like a crisis, but the system starts to behave like one. There is also a strategic feedback loop here that tends to get overlooked. When a country realizes that administrative controls over a material produce measurable downstream effects without requiring formal bans, it doesn't need to escalate policy to increase leverage. It can simply adjust precision. A slightly longer licensing review window, a narrower definition of high-grade export eligibility, a periodic tightening during domestic demand spikes. Each adjustment is small in isolation. Together, they shape global expectations, and expectations are where the real power sits. Because once manufacturers begin to assume that supply is not fully stable, they change behavior in advance. They overstock, they diversify suppliers, they redesign components. All of that has cost, and that cost is absorbed unevenly across industries. Defense sectors absorb it differently than consumer manufacturing. Aerospace absorbs it differently than automotive tooling. And all of it feeds back into procurement strategy. There's a historical parallel here that is useful but not perfect. Rare earths in the early 2000s, but tungsten is more structurally embedded in mechanical systems, not just electronics. That makes substitution harder. You can redesign software supply chains. You cannot easily redesign material hardness at scale without changing the product itself. So when tungsten export conditions tighten even slightly, the adjustment cost is disproportionately high relative to the visible policy change. And this is where interpretation splits. One view says this is standard resource governance, tight control over a strategically important industrial input managed to balance domestic demand and export value. Another view argues it functions as latent leverage, not actively weaponized, but structurally capable of producing pressure without explicit escalation. Both interpretations can be partially true at the same time. What is harder to ignore is the asymmetry it creates. Countries that depend on imported tungsten carbide inputs are not reacting to a single supplier decision. They are reacting to the structure of an entire upstream system they do not control. And that structure doesn't announce itself. It reveals itself through delays, reclassification, and the quiet reordering of who gets priority access when capacity tightens. We'll go deeper next into how this connects to defense procurement cycles specifically, because that is where tungsten stops being an industrial material and starts behaving like a strategic scheduling variable. There's a point in defense procurement where people stop talking about materials and start talking about availability windows. Tungsten sits right in that shift, because once you enter weapons manufacturing supply chains, the question is no longer, do we have tungsten? It becomes, do we have tungsten in the exact form, at the exact time, in the exact tolerance range required to keep production from slipping? That sounds bureaucratic, but it isn't. It is mechanical reality. A machining line producing high-precision components, whether for aircraft systems, artillery tooling, or armor-related applications, doesn't pause easily. It is designed to run continuously. Once it breaks rhythm, restart costs are not linear. They compound. And tungsten carbide is often the quiet constraint sitting underneath that rhythm. Here's the uncomfortable detail. Most modern defense manufacturing doesn't experience shortages as empty shelves. It experiences them as sequencing problems. A batch arrives late, so heat treatment schedules shift. That shift delays machining. That delay pushes assembly downstream. Suddenly, a delivery milestone moves by weeks without any single catastrophic failure. Nothing looks broken, but the system is no longer aligned. This is where export licensing behavior from China becomes structurally relevant, not because it turns off supply, but because it interacts with systems that are already operating near timing limits. And tungsten is unusually sensitive to this because of how specialized its processing chain is. We are not dealing with a broadly fungible metal market. We are dealing with a material that requires tightly controlled powder metallurgy, specific particle size distributions, and high temperature sintering conditions that are not easily replicated at scale outside a small number of industrial clusters. So when export approvals tighten at the refined product level, not ore, but powder, carbide, or high purity intermediates, it doesn't remove tungsten from global markets. It reshapes which industries can actually use it on time. There's a subtle distinction here that matters. A shipment of tungsten carbide might still be available in trade data, but not available in the sense that a defense contractor needs it. That difference between statistical availability and operational availability is where most misunderstandings happen. And once that gap exists, procurement systems begin to adapt in ways that are hard to reverse. They start over-ordering, they diversify suppliers, they stockpile. But stockpiling has limits, because tungsten isn't just stored as a lump of value. It degrades in usefulness if it doesn't meet spec requirements or if it sits outside controlled processing chains for too long before use. So the system becomes sensitive to timing again, even when trying to escape timing risk. Historically, there's a pattern here that resembles other strategic materials, but tungsten behaves more rigidly than most. Rare earths created geopolitical concern because of electronic supply chains. Oil creates leverage through price shocks. But tungsten is embedded in physical wear systems, things that literally grind against resistance. That makes substitution harder. You don't replace tungsten carbide in a cutting tool without redesigning the tool itself. You don't casually swap it out in armor-piercing applications without changing performance characteristics. So dependency is not just economic, it is physical. Now, to be precise, it would be incorrect to say export restrictions are uniformly tightening in a dramatic, linear way. That's not what the data shows. What we see instead are episodic adjustments. Licensing scrutiny increases during certain cycles, particularly when domestic industrial demand is high or when policy signals prioritize value-added retention. Those cycles matter more than any single announcement because global buyers respond not to bans, but to probability. If the probability of delay increases, even slightly, procurement behavior changes in advance. That anticipatory behavior is where structural leverage begins to form without explicit confrontation. And this is where interpretation becomes less clear-cut. One reading is straightforward: a major industrial economy managing a critical resource to secure its own manufacturing base while optimizing export value. That is standard industrial policy logic. Another reading suggests something more strategic: a system that doesn't need to explicitly restrict exports to create dependency pressure, because its position in refining already does the work. Both can coexist without contradiction. What matters more is the direction of travel. Supply chains that rely on a single dominant refining ecosystem are inherently more sensitive to administrative variation than they are to physical scarcity. And tungsten sits almost perfectly inside that vulnerability. So when people ask whether China is blocking tungsten exports, the more accurate question is quieter and more uncomfortable. What happens to global heavy industry when access depends less on mines and more on processing approval timing that can shift without warning? We'll close this out in the final part because the real shift isn't just about tungsten. It's about what this model of control implies for every other material that sits one step below finished manufacturing. There's a tendency, when you follow tungsten closely enough, to realize you're not really looking at a mineral story anymore. You're looking at a governance model for industrial time. Because once a country sits in the refining layer of a critical material, it doesn't just influence supply, it influences sequencing. And sequencing, what gets produced, when it gets produced, and what gets delayed, is where modern industrial power actually lives. That's the uncomfortable part of tungsten. Not that it exists, but that the world quietly reorganized itself around the assumption that its processed form would keep moving at a stable rhythm out of China. And that assumption held for years because nothing forced it to be tested, until policy started to shift in smaller, more technical ways. Export licensing structures tightened in certain categories. High-purity powders and carbide-related intermediates began facing more scrutiny. Not always consistently, not always publicly framed as strategic, but consistently enough to be noticed by procurement systems that depend on predictability more than volume. Now, there's a counter-argument worth taking seriously here. Some analysts will say this is not leverage at all. It's domestic balancing. China has a large internal manufacturing base, rising demand for high-performance materials, and environmental constraints that make uncontrolled export of refined industrial inputs politically and economically costly. From that perspective, tighter licensing is just internal optimization with external side effects. That explanation is partly correct, but it doesn't fully account for how the effects propagate outward, because global dependency doesn't care about intent. It responds to structure. And the structure here is asymmetric. Concentrated refining capacity on one side, fragmented downstream demand on the other. That asymmetry becomes visible during procurement cycles, especially in defense-linked manufacturing. Not in dramatic shortages, but in the way timelines stretch quietly. A delay here, a reapproval there, a batch that doesn't clear at the expected time. Each instance small enough to be dismissed in isolation. But systems don't experience isolation. They experience accumulation. And tungsten carbide, because of its role in high wear and high stress environments, sits directly in that accumulation path. It's worth being precise about what this material actually does inside industrial systems. It's not just strong metal. It is the point where mechanical energy meets resistance and does not fail immediately. Cutting tools, drilling systems, precision machining. These are environments where marginal differences in material quality translate into large differences in operational lifespan. So when supply becomes less predictable at the refined input level, manufacturers don't just adjust sourcing, they adjust design margins. They increase buffer stocks. They redesign tolerances. All of that has cost, and that cost is distributed unevenly across industries and countries. There is also a second-order effect that is less visible but arguably more important. Over time, uncertainty itself becomes priced into industrial planning. Firms start assuming that critical materials may experience administrative friction. That assumption changes investment decisions long before any physical shortage appears. This is how structural leverage forms without formal declaration, not through interruption, through anticipation. And this is where tungsten becomes more than a case study. It becomes a template. Because any material that sits in a similar position, concentrated refining, high switching costs, deep integration into defense or advanced manufacturing, can, in theory, exhibit the same sensitivity to administrative control. Which raises a broader question that doesn't have a comfortable answer. If industrial power in the 20th century was defined by control over energy flows, and the early 21st century was defined by control over semiconductor fabrication, then the next layer might be defined by control over processed industrial inputs that don't make headlines but determine what factories can actually run on schedule. Tungsten is just one of them, and the strategic implication is not that supply will stop. That's too crude to be realistic. The implication is that continuity itself becomes conditional. Now, I'm not fully convinced policymakers everywhere have internalized how sensitive these systems are yet. There's still a tendency to treat materials policy as a commodity issue rather than a timing infrastructure issue. But the data points the other way. And if that reading is correct, then the next few years won't be defined by dramatic export bans. They'll be defined by incremental tightening in the least visible parts of the chain: licensing, classification, processing thresholds, small adjustments, large downstream effects. So the real question isn't whether tungsten exports are being blocked in any absolute sense. It's whether global industry can keep operating on the assumption that the timing of critical inputs will remain stable when the center of refinement has both the capacity and the incentive to adjust that timing without ever shutting the tap. And that's where this story actually ends for now. Not with a shortage, with uncertainty becoming part of the system itself. If you want, next we can map which other materials sit in the same silent leverage zone as tungsten, because tungsten is not the exception, it's the preview.